We're in section 4 of chapter 8. And in this section, we looked at when we have smaller sample size versus the large sample size that we did in previous sections, so indicating we'll probably be getting into the t-distribution here. So let's look to see what we have going on. We have 6 coins. So our n is probably going to be equal to 6 as our sample. So the same type were discovered at an archaeological site if their weights on average are significantly different from, so this is different from, so their average, this is probably going to be our mu naught then, because that's our base that we're saying this is the base level that we have. Okay, and then it can be assumed that their province is not the site itself. The coins are weighed and have a mean of 4.73 grams. So this is our x bar, or the mu of our alternative, how we look at that, with a sample standard deviation of 0.18 grams. So there's our sample standard deviation. Perform the relevant test at the 0.1%, 1/10 of 1% level of significance. So our alpha is going to be 0.1%, which is 0.001. Assuming a normal distribution of weights of all such coins. Okay, the normal distribution of weights of all such coins gives us the ability to do the type of statistical tests that we've been doing, or using the test statistics that we have in this section. So that's handy. All right, so we're going to go in and do the systematic hypothesis testing procedure using the critical value approach. This is the one I will use, which we'll go through those 5 steps. So the first step is identify the null and alternative hypothesis. So our null hypothesis is that our average is 5.25 grams. Our alternative hypothesis is that the mean is not equal to that same value. Because I'm looking up above, it said significantly different. It didn't say greater than or less than, it just said different than, so it's just not equal to is what we'll have there. And this is at our alpha equaling, as I mentioned there, 0.1%, which was 0.001. And since this is not equal, that's a two-tailed test, so we're going to need our alpha at over 2 at some point here, which is going to be 0.0005. Okay, that's getting to be a lot less chance of there being an error, of a particular error taking place. Okay, let's go to 2. We'll look at our test statistic this time. As I mentioned, because our sample size is low, we have to use a small sample size test statistic, which tends to get us to a t-statistic. And we look here, our test statistic on the mean is going to be the x, well, it's not a z. I started putting a z in there, and it's not a z as the statistic, because that would be a standard normal, and that would be from a larger sample. So we're going to have a test statistic of t. And that's going to be our x bar minus our mu over our sample standard deviation divided by the square root of our sample size. And this is going to be with we'll have to put a degrees of freedom here of our sample size minus 1, so that's 6 minus 1, or 5. All right, so let's go ahead and calculate that out. I'll actually write 3 here this time, so our t is going to equal, this is going to be t with degrees of freedom 5. It's going to equal our x bar, which we kind of drew up above there, pointed down to the 4.73 grams. And we're going to subtract off our null hypothesis mean, which was 5.25 grams. Divide that by our standard deviation divided by the square root of our sample size. And this is, for me, I have to keep thinking, when do I use n? When do I use n minus 1? And n minus 1 is for degrees of freedom. And when I'm doing a sample standard deviation calculation, I'm using n minus 1 versus n. So I've got to make sure I use the right number in there, because I'll mess that up sometimes. Okay, so when we compute this, the value of the test statistic is minus 7.076. All right, so now we go to step 4, which is constructing the rejection region. So we're going to have a t distribution, which is flatter. Kind of silly looking there, isn't it, on my distributions? So we're looking at t distribution, and we're looking for, this is going to be two tails. So we'll look at the two spots here of what our rejection for this critical region for this t distribution. So we're going to do our t, this is going to be a 0.005 with degrees of freedom 5. And let's look that up in the table. We come back there, that for t at 0, 0, wait a minute, there are 3 zeros there, not 2. 0.005 degrees of freedom is going to be 6.869. So we got 6.869 or greater, and minus 6.869 or less is where our rejection region is. Our value is minus 7.70 or 7076, which is in the rejection region. So we are going to reject the null hypothesis. So the data does provide sufficient evidence at the 0.1 level of significance to conclude that the average weight of all such coins is different from 5.25 grams.